Hello and welcome. So in this video lecture, we are going to talk about different problems related to description logics. So here we will be solving several problems. Basically, these problems will be belonging to the categories like representation of knowledge representation using description logic or interpretation of some represented knowledge in description logic. So either we'll be talking about representation related problems or we'll be talking about interpretation related problems. To start with, we'll be discussing the representation related problems, right? The first kind of representation related problems that we'll be discussing. So we are talking about representation related uh, problems in DL. So the first type of problem that we are going to discuss is uh, you are given with a description logic statement. You have to convert that into its corresponding natural language statement. So the problem statement goes like this: transcribe the following. Transcribe the DL statement into natural language statement. Into natural language statement. Right. So let us take an example to start with. So this is the kind of DL expression that we have: human and female and for all has spouse, nothing, right? So this basically represents the female human who does not have any spouse, right? So this is a kind of the corresponding natural language statement is this. So female human who does not have any spouse. Now let us think about the second problem. In the second problem, we have something like this: human and not female and has sibling there exists has child thing, right? So it will be like non-female human being who has got the siblings having at least one child, right? So non-female human who has a sibling having at least one child, right? The third problem goes like this: the movie intersection conjunction for all has acted negation of German, right? So apparently you can say that movies that have only actors only that are not German, but the better way to say the same thing is movie that does not have any German actor, right? So the movie that does not have any German actor or does not have a German actor. So basically what we are doing here, we are making this equivalent to movie and negation of there exists as actor German. So this does not have a German actor is represented by this. So first of all, if you have this, it means does have at least one German actor and we are negating that, right? So the other problem that we can discuss is the uh, company, then you have there exists as location uh, UK, and this is a kind of nominal, you know that, right? And uh, mm, not for all has location UK. So the first restriction says that the companies that has got at least one location in UK. The second the second expression is saying that it is not the case that all the locations are in UK, right? So basically, the natural language statement for this is companies that have at least uh, one location that are at least located in UK, but all the locations are not in UK, not in UK. So there are many problems. Let us have another. Say the human intersection works for all has location, say UK. So human that works for the things that are located only in UK, right? So human who works for uh, the things, but we can say companies, or let us be very specific, things that are located only in UK, right? So we can also work on the reverse problem where the description is given in the English language, then you have to convert them into the corresponding DL form. So the second type of problem, representation related problem, is this from natural language statement to DL statement. So what problem we can think of? Okay. Uh, so let's say we have something like childless married person, right? So we are defining some concept which we call as childless married man. So this is what we are defining. And what is the definition? The definition is human or man who is married but does not have any child, right? So the class that we are defining is childless is any man, childless married man. This is the class that we are defining, and we are making this to be equivalent to male and has spouse, has at least one spouse, and does not have a child. So it is not the case that there exists at least one child, right? Or you could have written this thing to be for all has child to be bottom, right? uh, how we could represent, so this is the A, B, something like companies which have premises in the UK or in the USA, right? So it will be kind of company, it will be a member of company first. Then we say there exists at least one location. It is located at least in one location, and the location is either UK or USA, right? Now these are kind of individuals. So you need to convert them into nominals first, UK, and then take the union, right? And it should be this location is either UK or US. It is the disjunction of the closed classes. That is what we are using, right? Uh, so how do you model something like this? So see, parents working for a company that has premises outside the USA, right? Premises outside the US, right? So first we need to model parents, right? So how do you model that? So parents, they have at least one child. So you say has child, and by this I am modeling parent, right? And those things they works for uh, a company, right? So something that this person or parent work for is a company. So that is the first constraint. The second constraint is that this company has premises outside the USA, right? So it has location something other than USA. So in order to take negation or complement, you have to convert this USA individual to a class first using nominal, right? Now let us look for other few problems and then we'll be going to discuss few other related problems. Uh, so for example, how do we okay. Uh, Let us try to model something like this. The human, all the human, all human who have at least who has at least one non-alcoholic parent is also not alcohol. So this is what we are going to represent, right? So let us assume that we will be using this has child relationship, right, as we were using earlier, right? So this relationship, right? So you say human. So what we have here? So first of all, we need to say if something is a human and has at least one non-alcoholic parent, then that human is also not alcoholic. So we have a subsumption here. So is this will be a kind of subclass of the non-alcoholic, right? So human. So let us first represent this human and so we need to say that has at least one non-alcoholic parent. So basically you need to model there exists at least one parent who is not alcoholic, and that means that person is not alcoholic, right? So something that is a member of this class would also be a member of this, right? Now we have mentioned that we will be using this has child relationship, not has parent relationship. What exactly we'll be doing to conform to that requirement? We just say has child inverse, right? Uh, so there would be many other problems. So let us now stop at this point to discuss this kind of representation and move to other kind of problems related to representation of things using description logic, right? So another particular problem category can be of interest is identifying logic family. So identifying real logic family, right? So what we will be doing here? So here the question that would be provided is like there will be a natural language statement. Then you have to model that into a logic family, according to a logic family. You cannot go beyond that logic family, right? So using that logic family like ALC, Shoik or showing, using that logic family only you have to represent the thing, right? So either you can say that the representation that have been asked to do cannot be represented using the input logic family, or if it is possible then you come up with one representation, right? So so let's take one example and try to see whether, so the example goes like this. We want to model mother of Alice. Now we are asked to model this in ALC or using ALC, right? So first of all, how do we model this? So if we are just assuming that this is a concept which is equivalent to female, so mother is a female, and as the person is a mother, has child, and the child is, at least one child should be Alice, but Alice is one individual, so you cannot just directly write Alice. So you need to convert this into nominal first, then you put that individual inside that nominal. So this is the way you can represent this concept. But the question is, we have to do this modeling with ALC. Now in ALC, the nominal is not allowed. Nominal is not allowed, right? So as this is not, so if nominal would have been allowed, so we have would have this symbol, right? But we do not have this symbol in the logic family name. So we say that this cannot be represented in ALC, right? But it can be represented using something called ALO, right? But not in ALC, right? So mm, let us have another example of this sort. We are trying to define something like academician. So academician is a person who teaches at least say two courses. Two courses, right? So how do we write this? Academician is equivalent to person, so I'll say any person and greater than equal to 2 teaches course, right? But you see again, this cannot be modeled in else. Why? Because you have something like this, and which is basically the qualified cardinality restriction. And the symbol for qualified cardinality restriction is Q, and that is not available in ALC, right? So what you can say that it can be modeled or can be modeled in ALQ, right? Uh, Now let us try to model this. Alice is a grandmother. Now, looking at this statement at the first glance, you can see you have an individual. It might occur to us that as this is an individual, we might need to convert this into its nominal form, as we did this for this example 1, right? But we'll see that we do not really require to convert this into nominal. So why? First, we will be defining this grandmother concept. So how do we define grandmother concept? So grandmother is a female, right? And uh, at least has one child, and that child has got at least one child, top anything, right? And we say that Alice is a member of this. So this is not a T box statement. So this is not a T box statement. This is an A box statement. Right. So apparently it looks like that it will not be belonging to LC. Now if you see that this is going well with the ALC, you can represent this very easily using ALC. So yes, we can model this in ALC. No, we cannot model this in ALC. We cannot model this in with ALC also, but we can model this statement using ALC, right? Uh, Now let us try to model something called faculty member is a person who is not a non-teaching staff and teaches at least 2 courses, right? So faculty member is a person who is not a non-teaching staff and teaches uh, at least 2 courses. We are defining faculty member class is a subclass of person intersection. It's a non-teaching staff and uh, teaches at least 2 courses. Right. So it is belonging to the class say ALC, logic family ALC, and this part is getting us Q, right? So and if you allow transitivity, then it becomes SQ, right? But the minimum logic family that you have to use is ALC, right? Now let us try to define something called uh, uh, teacher uh, no, let me write co-teaching faculty member, co-teaching faculty with 2 PhD TA. So this is the kind of class that we are trying to represent, right? So we say a co-teaching faculty member with 2 PhD TA is any person, any faculty uh, who or any person, let me make it bit more involved, any person who is not a student and teaches at least one course that are that have that are taught by 2 PhD students, taught by at least students, right? So you are defining co-teaching faculty with 2 PhD, co-teaching faculty with 2 PhD PA to be equivalent to person who is not a student, right, and teaches at least one course, right? Teaches at least one course, and there is another specification for this course that is not that are taught by uh, that is taught by at least 2 PhD students, right? So and uh, greater than equal to, right? We could have written is taught by, but we know that this teachers is an inverse. Is taught by is an inverse of teachers. So we just say teaches inverse uh, PhD student, right? Now, what would be the logic family, minimum logic family for this? So we have this ALC plus we are having inverse, right? And we are having qualified cardinality. So put together, it will be SIC, right? Now, let us assume that with this, we have something, some more statements into this T box. What is, and the statement that we have, teaches is a sub-property of involving, right? So this basically is represented by the role hierarchy. So we have H here. Now, if we have this, so let's say this is a concept C, concept expression CE. So CE plus this, then we'll have the logic family to be SHIQ because we are adding H to SIQ, right? So that's why this is becoming SHIQ. Now, let us turn our focus into other kind of problem. So the third kind of problem in this particular uh, mm, DL representation related things is conversion of DL statements into first order logic statement, right? So let us have one such example. So activities of happy creatures are either sleeping or eating, right? So you can convert this into description logic by writing something like this. Happy creature is a subclass of something that has only activity to be eating or sleeping, right? So as we have a subclass relationship, this will be modeled with implication, forward implication, and something that is a member of happy creature. So this class will be converted into one unary predicate in the transformation, right? Creature X, and we want this to happen or hold for every X, right? Now we can directly model this for all with for all in first order logic. So for all the activities that this X has, right? So X has the activity Y that will imply. So that's how we convert this for all statement. So if we have that for all RC, it will be converted to be the RXY for all Y implies CY, right? So we are doing the same thing. So that means either Y is one eating activity or Y is a sleeping activity, right? Now let us try to model something like this. Alumni of successful institutes are either scientists or director of research labs that employ uh, some scientists, right? So you are kind of making a statement about uh, successful institute, right? They are saying that successful institute is something that has alumni. So for all the alumni, they are either scientists, right? So either they are scientists or director of a research lab, right? So uh, at least is a director of uh, a research lab, and that's how the now we'll be modeling that employs some scientists. So it is a research lab, also it employs some scientists. So this is how we'll be writing employs scientists. So for their exists employ employs scientists, right? Now let us try to convert this into its first order logic. So you'll be writing for all x successful institute implies for all the alumni, if X has an alumni Y, so what does that mean? So it will be so this is our R and this entire thing is our C. We have got one for all our C, and we know how to model this for all our C, right? So we say that has alumni implies Y belongs to C, and what is our C? Our C is this entire part, right? Now let us try to convert this C, right? So this C is either a scientist, so Y is either a scientist, Y, or their, now we need to model their axis, and we really can model their axis by their axis symbol in first order law. So there exists a research lab R where Y is a director of R, right? Is director of YR, right? And at the same time, R should be a research lab. So a research lab R, and there exists an employee where R employs E, R employs E. So now we are converting this, right? And E is a scientist, right? So this implication, the scope of this implication is this part. So this is how we can convert a kind of complex expression into corresponding first order logic expression by looking at the expressions in a piecemeal manner. So here what we are doing, we are just assuming that this is one class expression, say C1, and we are making this C1 to be subclass of for all RC, and we are assuming this has the alumni to be R and C to be this entire expression. Now we know that how to convert this. First we convert this, then we go into the inner part of the expression, right? Now how to model something like, so let us come to a third modeling problem in this category, is every organization has at least two members. So let us try to model this. Every organization has at least two members, right? So the description logic representation for this would be organization is a subclass of for all two has member. Right? You can have T or can ignore. Right? So as we did earlier, we'll be writing for all X organization X, and this implies we need to make sure that there is at least there are at least two members. So we say there exists M1 and M2, M1 and M2. First we assert that this M1 and M2, they are not equal, they are different. And then we say as member XM1 and as member XM2.